Hello, everyone. I'm Ana Paula Garcia Alonso, and I study biomedical engineering at Tecnológico de Monterrey, Campus Guadalajara. This summer, as part of the Robotics Institute Summer Scholars, I'm conducting research in haptics and educational robotics. I have approximately 50 of my fellow summer scholars here in the room with me today, from which I will be facilitating questions at the end of this session. So at the end of this session, my fellow scholars, Sujan and Vihan, will be helping facilitating questions from the online YouTube streaming. And on behalf of the RIS 2022 class, I would like to officially welcome everyone to this RoboLaunch session. It is my honor to introduce today's speaker, Dr. Melisa Orta Martinez, Assistant Professor here at Robotics Institute of Carnegie Mellon University. During her years in Stanford, she earned a master's in electrical engineering, followed by a PhD in mechanical engineering. She is now a lead innovator combining areas of robotics, haptics, human interaction, and education. Through her lab, the Social Haptics Robotics and Education Lab, also known as SHRED Lab, her main focus of interest is to develop low-cost open-source robotic technology and its effect on learning, as well as deepening human-machine interaction through the sense of touch. Thank you in advance for speaking at this RoboLaunch session, Dr. Orta. We look forward to your talk.
Thank you, Anna. Well, hi, everybody. So as Anna introduced me, I'm Melisa Orta Martinez. And today I'm going to talk a little bit about research that we do in my lab, as well as my trajectory into becoming a professor here at Carnegie Mellon. And I'm going to kind of combine the two and let's see how it works out. And so the first thing is that, yes, and I mentioned my research combines the areas of haptics, robotics, and education. And in order to understand a little bit more about those topics, I think I need to introduce one in particular that people are not so familiar with, which is this topic of haptics and what is haptics. And so haptics is just basically just having to do with the sense of touch. And in order to better understand just how powerful that sense is, we're all going to do an activity together, okay? And you're not going to leave me hanging. We're all going to do this, okay? So I want you to just stretch your arms out without hitting anybody in the face, and then point your fingers, and then try to touch your fingertips above your head without looking. And it takes like a couple of tries, but you can do it, right? And the reason why you can do it is thanks to our sense of touch. So a lot of people don't think about these, but every time I take a step, every time I walk around, I don't actually need to think about the fact that I'm taking a step thanks to my sense of touch. My sense of touch actually combines two very powerful senses. One is the cutaneous sense, which are all of the little mechanoreceptors and thermoreceptors that are in my skin. The other one are also sensors in my muscles. And so when we did this exercise where I like stretched out my arms, actually I know through sensors in my muscles that my arms are stretched out, both by like the forces that are being applied to it, by the fact that my muscles are now stretching, and I know where all of my bodies and my limbs are in space, thanks to my powerful sense of touch. And so when we're thinking about, okay, how do I study the sense of touch? How do I build devices for the sense of touch? You really have to combine a lot of areas together. And so we're actually combining a lot of areas of neuroscience, which tells us like what exactly is happening in our brain when we're touching things, right? Like how exactly is our brain combining those signals and giving us the senses and the feelings that we're feeling. We're also combining areas of psychophysics, which actually is the area that allows us to do human subject experiments in order to further understand how people are perceiving things. And then we also need to design these devices. And so that gives us robotics. And now in order to understand now kind of where we are with all of this technology, what I like to do is to draw a parallel in comparison to our sense of sight, right? And so in our sense of sight is pretty well understood. I mean, of course, like, if there was like, you know, a vision researcher here, he might come and punch me in the face because they're like, no, there's still a lot of things to, of course, there's always things to find out. But in broader sense, we kind of know what's going on, right? In our eyes, we have these three cones, each one of the cones, and some people have one repeated, but in general, we have these three cones. They all sense light at a different bandwidth. And then our brains combine those bandwidths together, right, of red, green, and blue in order to give us all of the images, right? And so if I'm like looking at my dog in this image, right? And then I take a picture of my dog, basically what I'm doing now, I can decompose that image into the same type of bandwidth that my eyes would be seeing. And so every single pixel, I can decompose it into just three numbers, Those three numbers are kind of a weighted average of that red, blue, and green light. And now I can feed that to a computer. And thanks to the fact that the whole cycle is so well understood, as in I have the thing that displays the thing, I have the thing that captures the thing and everything. Now we have these fields of computer vision and like autonomous driving and all of these things going on just because it's so well understood. So we can basically just decompose the whole problem into numbers, and now I can just feed them to the computer. A computer can do the work for me. Now, the problem with touch is that we're not quite there yet. So on the one hand, I can like pet my dog, but even that descriptive language of what exactly is happening, right? Like it feels fuzzy. Okay, well, what's fuzzy? What exactly are those signals in fuzzy? Like what are these pixels that would actually, or the numbers that would actually make something feel fuzzy or not fuzzy? That still isn't understood. We do know that in our skin, we have these different mechanoreceptors, which are like nerve endings that will trigger at different frequencies, right? So if I touch something with a lot of texture, which creates vibration, then I know that my protein corpuscles are gonna be firing in my brain, right? And if I touch something that's not, where I'm not gonna be feeling something so kind of grainy, maybe like an edge or something, then I know that it's gonna be something like my Meissner corpuscles or my Ruffini corpuscles, the ones that are gonna give me some information. But how exactly all of that gets combined in our brains in order to feel what we feel? What exactly are the properties of materials that we are actually feeling and how we're feeling them? We don't understand that yet. So we don't have that RGB for touch. So there's a lot of work to be done. The other kind of problem here, maybe not problem, but opportunity or whatever, is that touch is very active. And so depending on how much force you are applying to objects or how you're applying that force or how you're feeling those objects around, you will feel different things. And so that's different than from the sense of sight. Like, of course, if I move my head really quickly and I like feel different things or like see different things, right? But it's not quite the same. Like you would touch literally as you're like pressing on different things in a different way, you will feel differently. And so that's all of the information that we kind of need to take into account in order, if we were thinking like, oh, what would happen if I could just like put some VR goggles and then some like weird gloves and I could actually like feel virtual apples. All of that is what we need to take into account. And then the last kind of bit is that bit that we talked about, which is like we not only have sensors in our skin, we also have sensors in our muscles. And so now we need to try and understand all of that in order to design actual haptic devices. And these would be the devices that would interface with us and a virtual world, for example, right? If we wanted to at some point feel virtual apples. Now, even with how little we understand, there's still a ton of stuff that we can do, and that's why we do research in it. So let me show you an example of a device that exists nowadays. It's called the Phantom Omni, I think. Well, it's been bought around by different companies, and so kind of forget what it's called at the moment, that device. But the idea, this is a kinesthetic haptic device. Now, as we saw, kinesthesia is the one where we sense forces, right? And so the way this works is that you're gonna be grabbing onto that virtual pen, right? And you're gonna be sensing that virtual flan in space, but not as if you were touching it with your finger, but as if you were feeling it through a tool. So you don't directly feel the moisture, things like that, but you do feel the forces that you would feel, right? And so that's something where basically we're building a robotic arm and you're grabbing onto that robotic arm and it's rendering forces to you. And now you can feel virtual objects in space. So not quite the same, but still very powerful. And now the other area of research where that's very powerful is, okay, what if now we try to directly manipulate the skin? And so this is a device that I like a lot because it targets one problem in particular. So what it does is it's this little tiny robot that will stretch your skin around. And then, well, in this case, the user is wearing two of them, and then it's picking up some virtual cubes. And this was actually done for a study on weight perception. And can we change the way people perceive the weight of virtual objects? And now this comes from a very, very awesome principle. And that is that every time we hold onto an object, the way I know how much weight it actually has and how much force I have to apply to grab it is by how much my skin stretches. So our bodies are incredibly lazy and they always want to be doing as little work as possible, which makes sense. So when I grab this water bottle, I'm not actually going like and grabbing it super tight. What I do is I grab it in an almost slip condition. And so, and my body knows when that condition happens, and so it doesn't actually slip from my hand by the fact that my skin is stretching. so my skin will stretch more if I'm grabbing something with more weight. And that's how I know how much something weighs. And so what they did is then people would perceive things as being heavier or lighter in space in the virtual reality world if your skin stretched more or less. And so that study. And so then, as you can see, like even with these advances, that's not nearly as good as you actually being able to like completely feel that cube in space, right? Like there's still a lot of advances to be made. One of the things that is kind of stopping us from going to feeling objects in space is the fact of how many of these mechanoreceptors, the sensors we have in our hands. We have thousands of them. And so in order to trigger each of them, you would need basically, if you think about a pin array, they would have like thousands of things going up and down so that we could actually go to the resolution that our sense of touch can actually go. So there's still a lot of work to be done. And so that's one of the areas that we focus in my lab. So on the one hand, we try and see, okay, so those robots that you saw are thousands of dollars. And so how can we design devices that are cheaper so that we can make kind of haptic research more broad so that more people can contribute to it? So that's one. How do we make these devices that are open source, maybe 3D printed and cheaper so that more people can do research? And now the other, another area of research that we do in my lab is how can we now make novel materials so that we can actually target all of our mechanoreceptors with more precision, right? So that we can actually do, if you wanted to grab a virtual apple or something, you would actually need to have a long resolution. It's about 0.5 millimeters of resolution that you would need, and you would need a lot of these pins going up and down. Well, that is kind of an impossibility if you think about mechanical systems. But if instead we think about having maybe a composite, right, or some soft skin that you wear, and then you can actuate that soft skin. So maybe that's a way to do it. And so we're experimenting with different types of polymers and magnetic particles. And here you can see a video of one. Let me see if it plays. Yes, it plays. And one actuating. And so you would wear a material like that, and then magnetic fields would actually make it actuate on your skin. And that's how you would feel different sensations, right? Cool. Now, the other thing to think about is even though we are saying like, okay, we can like completely reproduce a virtual world, there's still a lot of applications that would benefit from the sense of touch and from doing haptic technology. And so we can think about applications, for example, in surgery, right? So you can see in the middle top there, a picture of a surgeon operating with a surgical robot, right? And so as we saw a little bit earlier, the way we control our own bodies is through touch, right? I don't need to know or to actually look at where my arms are in space to know where they are. But then when you think about how does a surgeon actually conduct an operation using the surgical robot? Well, actually the surgeon sits at a console that you can see right there, and then the robot is next to them, and then they have to kind of control it to just the sense of sight. And if you ever hear records of astronauts in space or something, when they're trying to control a robotic arm, just using your sense of sight is incredibly hard because that's not the way we learn to control our own bodies. We learn to control our own bodies using the sense of touch and by feeling. And that's also how surgeons train, right? They know when to stop cutting because this tissue feels differently. But now they have to tell a robot when to stop cutting just by how it looks. And that's really hard to do. So one area of research that's very prominent in haptics is how do we bring back the sense of touch to those robots so you can feel what the robot is feeling and control the robot through your sense of touch. Another area you can think about also that has to do with medicine, and that's in the top left there, it's in medical training. So a lot of, the procedures when you're training to be a doctor are done in cadavers or something, it's very risky, right? Once you actually go to a real person. So can you increment the amount of time that surgeons can train if you actually do this through virtual environments and through virtual worlds and teach them how different tissues should feel, how they should detect cancer, etc., using the sense of touch. And then of course there's applications in rehab where we can actually control the body, exoskeletons, etc., or in gaming, right? There's a lot of applications in gaming. And now I'm going to take a brief pause here in order to introduce the application that I'm most interested in, and I'm going to motivate it in where I come from, if that's okay. And so I'm originally from Mexico. I was born there and I lived all my life until I came to school here for graduate school. And if you don't know much about Mexico, well, you should know that it's a beautiful country and you should all visit. but also it does have its social problems. Mainly, it's a very, very corrupt country. The numbers now is like something like 98% of crime doesn't get prosecuted or something like that. And a lot of the time, they're the people who provide you the services, policemen, etc., who conduct the crime. I can't tell you how many times I've been stopped by a policeman and he has asked me for a bribe, right? And so it's not very safe. There's not a lot of services. And I'm going to tell you through the story for why I believe one of the solutions might be. And now to start, I'm going to tell you in all honesty, and we're all going to laugh at this, and then we're never going to talk about it again, but I never wanted to be an engineer. There was no way. I'm going to show you what I used to do. And really with the way I saw, okay, how I can help my country, I thought, okay, the way I can help my country is by being like United Nations delegate or things like that. Because really what I did when I was growing up was a lot of like acting and singing and doing things like that. And that's where I thought I was going to do. And so then when I was in high school, there was one professor in computer science who gave us all, like the whole high school class, a problem to solve, right? And he was like, oh, if you can solve this problem, you should consider a career in engineering, right? And I was like, oh, there's no way, like never gonna be an engineer. And then I solved it and I was like, oh, that was actually pretty cool. And then when I showed it to him and I was like, hey, I solved it, he looked at me, he was just like, oh, you're a girl. And I was like, okay, I guess I'm going to study computer science. And so then I started that. But so it's proof, because a lot of the time somebody will tell you this and they'll tell you like, no, I'm the last person. And you don't believe them. So you believe me, we're all going to laugh at me for a second. And this is the kind of stuff that I used to do. So that's me advertising pods on the TV. And yeah, that's what I used to do. And that was what I wanted to do. I wanted to be like an actress, whatever, but nothing having to do with engineering. Now I will tell you, if you know nothing of engineering and you enter a computer science program, yeah, I mean, you're going to fail. So I failed and I failed out. And then I transferred. I was lucky enough to have like supportive professors who saw something in me. And so I transferred to electrical engineering, because when you come in knowing nothing about computers and computer science, you learn that everybody else has been programming their entire life and everybody there knows everything about computers, and it sucks. And so I learned, okay, electrical engineering maybe is a little bit more hardcore. It's less likely that people are just like building circuits in their house. So I did that, and then that was fine. And then I got the chance to do an internship, kind of the way you guys are doing an internship right now, where I got the chance to go and do an internship in Germany and work in a research lab. Really? That's awesome. Yeah, I went to the Heinz Nixdorf Institute, and then I was only supposed to go there for a couple months, but then they ended up allowing me to stay for a little bit more. And then with that, I got a publication, and you should always, like, if you're interested in that, you should try to get a publication out of whatever, second author, whatever. There's a lot of the things that what universities look at. And so with that, I was able to enter Stanford University. I honestly did not know about PhD. So I only applied for a master's, and I will say right now, don't ever only apply for a master's. Even if you're thinking, oh, I only want to do a master's, just apply for a PhD, because it's really hard otherwise. So anyways, I'll tell you the whole story, but I went to Stanford. And yeah, that was also really hard. I almost failed out again. Luckily, I found a group of friends who helped me out. But coming from Mexico and then starting, sitting in like linear algebra, and you're like, oh my God, what the hell is going on here? It's really, really hard. But you find your people and they help you out and you get it. And then by the end of it, they were all PhDs. And so they told me like, oh, maybe you should apply for a PhD. But I was kind of done. I was like, I have a lot of debt. I want to go work. And so I worked at Apple. For a little bit in the human input devices group. But they're always on the back of my mind, there was this thing where I was like, oh, like I really came here to help my country. Like, am I really helping my country by building trackpads? I'm not so sure. so then I decided, okay, maybe this job is not so much for me and I should try to go back and do something. I will tell you, coming back to school after is incredibly hard. Like the normal trajectory is you do master's, PhD, right? So if you do master's, then go away, work, and then PhD, like nobody wants you because you're already like, they're like, well, I don't know, like, are you going to be able to do research? What? So it's really hard. So that's why I always tell people like, if you think you're going to stay, just try it out, apply for the real program, see if you like it. If not, you can, there's ways of coming back, but it's really hard. So I was very lucky to find an advisor that believed in me and allowed me to stay. And again, so then I came back for PhD. And I won't say like, oh, it's all smooth sailing from there or something. Like PhD kind of sucks. it's a lot of, like you're kind of by yourself and you're working on a problem and it's really hard and you're like, oh my God, like it's really hard. And you see all your friends making money and you're like living in a 4-bedroom with roommates and like eating ramen and being like, oh my God, what am I doing? But, but I feel like for me, it was worthwhile, right? And mostly what I learned from all of these is that I think that the area that, because I struggled a lot with this, is what I figured out is there's a lot of different types of people. All of us learn differently. And so what I really wanted to do, and so in my trajectory personally, everybody along the way always told me like, oh, no, you can't do this. Or like, you're not gonna be able to do this. You're not gonna be able to do this. But if you have a growth mindset, you're like, okay, I'm not gonna be able to do this right now. And I'm gonna be, and if you're fine with being the worst in the class, and like, I'm the worst in the class right now, but maybe later I'm not gonna be the worst in the class, and you keep learning, then it's fine. And so basically what I wanted to do is research more about education, how different people learn, and then try to build devices to help people learn in different ways. Because basically the way our educational system is structured right now, even though it is very well known that as babies, as children, the way it is natural for us to learn is through moving, exploring, doing things, sensing things, touching things, then at some point, somebody decided that actually the way we should try and learn is we should all sit down and be quiet and not do anything. And so that's not how our bodies learn. And so, so part of my research, what I try to do is, okay, so there's a lot of research in like how you learn if you're like hearing something or if you're explaining something, etc. But how about if you're feeling something, if you're like playing with something, if you're doing something hands-on? And so that's why I do a lot of my research in. And so some of it is in, oopsie daisies. So, okay, this is supposed to be a video. Okay, it doesn't matter. I will explain. So part of it is in building devices where you're actually playing with an interface like this. For example, this one has a bunch of springs that you can like drop into the interface, and you can play with them, you can play with the gain, etc. And you can also feel them. Oh, now it's gonna play. Okay, awesome. Yeah. So you see, okay, so you like add a spring, and then you have a device which allows you to actually feel the way that spring would feel. Right? It's a little bit hard to explain with haptics without actually being there and feeling it. But the idea is that now the concepts are not just abstract, but it's actually something that if you change something in a math and in the equation, then something actually feels in the way that device behaves. You can actually sense it. And we have done these, actually these same experiments in middle school, where we've gone in and tried to teach physics and teach them about springs and dampers and things like that, and how equations change and how that changes the field. And that has been pretty successful, even for young kids. Now, the other thing that I also like to look at a lot is math. Now, I believe math is very powerful. It's one of those subjects where basically a lot of people they believe they're not good in math, and so then they stop. And then now they don't go into engineering and don't go into doing anything of what they want to do just because they believe that math is too hard or they're not born for math. But there's a lot of research that actually states that math is very creative, that actually once you go away from just the math as computation, math is very creative. It requires different processes. There's a lot of different processes in the brain, which I'm going to talk about in a second, that actually have to do with math. And so one of the things that I try to do is, okay, so the way right now the teachers try to give you some grounding into my abstract math functions is by drawing something on the screen, right? But then what if you're not a visual learner? And what if that doesn't translate to you? And so same thing, what if we could feel very abstract concepts? And so in this case, we ran a study where you can see, just for illustrative purposes, that purple line, right, is how the equation changes. But actually for the people that we did the study with, you couldn't see the purple line. You could just feel the purple line, if that makes sense. So as you were exploring a trigonometric function, then you could see the relationship between the function and the unit circle and how that changes, but you could also feel it. And so now changing the amplitude, changing the frequency has a real concrete thing now. It's not just something abstract or something that somebody's just drawing for you. And then, as I was saying, there's a lot of research which shows that the actual neurobiological cognition of math learning is very complicated. It's not just one area of your brain lighting up, it's a lot of different areas and a lot of different connections that have to be made. One of them that seems very interesting and very weird is the area of your brain that's basically kind of like a picture of a hand. And then even in people who like don't count with their fingers, or they're old enough or they're not counting with their fingers, that area of the brain lights up. And so math teachers now, or like math researchers are telling math teachers and educators, because it used to be that people would tell you, like, don't count your fingers, right? And when you were little, I don't know, you guys are pretty young. But when I was little, the professor would walk around with like a stick, and he would be like, if he saw you counting with your fingers, he'd be like, jump. And then probably not for you guys, you're too young. But you know, it's like, don't count with your fingers. You have to be able to count in your head and do everything in your brain. It's like, well, actually, your brain is counting with your fingers anyways. And people who are musicians and use their fingers a lot are sometimes better at math. So maybe we should be counting with our fingers. And so what we did is we did a study in which, and this idea of like being good at your fingers and sensing your fingers, it's called finger perception. And so there's been some evidence that people might be finger perception, and you being good with your fingers, especially at a very young age, around 4 or 5, might be correlated to how you learn math. And so what we did is a study where we created this device in which we basically said, okay, what would happen if kids actually learned math and finger perception at the same time? So basically you correlate each one of your fingers to a number, and then the students are doing math activities, and as they're doing them, they're kind of answering and playing like a piano, sometimes 1 button at a time, sometimes 2 buttons at a time, but they're just like moving their fingers and allocating a number to each one of their fingers. And so we saw that there was some correlation between students being able to be good at those activities and people learning better math. And I ran through this presentation because I thought we had less time, but yes, are there any questions? Or anything else you want to talk about?
Yeah, so we have one online question, and that is, what's the easiest way to introduce haptics as an interaction?
So a little, what's the easiest way to introduce haptics? You mean like as a topic, like in school, or like as like what's the easiest device that you could make if you like wanted to have a haptic interaction with your computer? Can you clarify a little, or maybe there's no way, but, and I'll just make something up.
Something like a gameplay.
Oh, something like a gameplay. Okay, now that makes sense. Okay, so I guess one of the main things in haptics is that because there's not that many devices out there, but you kind of use the actuators that are out there. And so in our phones right now, one thing that has become very prevalent is a vibration motor, right? And so basically what you have is just a little mass attached to a shaft, and then which vibrates, and every time it goes round, because the mass is offset from the rest of the mass, it goes, and then if you do that pretty fast, and now you get a vibration, right? So then that's the easiest way, and that's in almost all of our controllers now. What that does is it affects it triggers the high frequency mechanoreceptors that we have. So we saw that we have 4 different types, right? And so the mechanoreceptors, the Pacino corpuscles, are the ones that are out there. So the easiest way to just make something that has some interaction is like, okay, I'm going to use just this actuator that is out there. I'm going to slap it on something. And then, you know, and there's been pretty good research, like it does become easier to type on your keyboard on your phone, right? If you're having the little vibration every time you press a key, because that's like an alert. So these Pacino corpuscles are like, oh, there's an alert, there's something coming. So it gets you aware of that. Now there's a lot more opportunity. So I would say easiest way, just like slap a vibration motor and something, and now you have a little haptic interface, and you can make it react to, I don't know, like your phone rings, the vibration goes off, right? And or like you have your controller and it's like somebody shoots you, the vibration goes off, right? And so that gives you an interaction. Now, of course, there's more opportunities, but in order to trigger the other mechanoreceptors and to make interfaces that are more immersive, now we need to make better actuators, basically. Yeah. Yes. Yes.
And Anna will restate the question as well, so that we
Yeah.
can go online.
So do I stand up?
Yeah.
My name is Philip.
Hi, Tickles.
I think I kind of like knew kind of five people who coming here to like public content. I'm Nigerian. I was born there. They say my goal, like just like Mexico. I realized how bad it was. Everyone just corrupt. Right? So my question is, yeah, I do eventually want to go back home and help my country. That's why I came here.
Yeah.
What are, I guess when I put it for you, what is that that you focusing on in that aspect?
Yes, no, that makes total sense. So if I can rephrase the question, our friend is from Nigeria and he also wants to come here to learn and then go back to his country. So his question is, how am I focusing on going back and helping back from here, right? And so, yeah, so what I realized, I mean, working for Apple, and then I also kind of did a startup on the side, is that really just going back sometimes, at least for me, wasn't the right choice because all the resources are here. And this maybe, I don't know if like, how Americans feel about that, but that's kind of the truth. Is like here, there's just so many resources in like, I can just online order on McMaster and I have my parts to build a new system in 2 days, right? Whereas in Mexico, I know that I would have to go to the center of the city or something, and it would be like a 4-hour drive. And I would have to, you know, like see, and there's not that much available. Here also the funding. I mean, in Mexico, when I talk to professors there, they're talking about grants that are super hard to get, and they're like $1,000, right? Whereas here, the grants that you write for the NSF are for millions of dollars, so you can hire like teachers and everybody and do like a big study. So my whole thing is that everything I do is open source, everything's online, so anybody can build it. And of course, I'm trying to figure out ways to do education online so that anybody could learn the things. But I also understand, just from a practical standpoint, that if I was back in Mexico, I would have not nearly enough resources to be able to do the research that I do and to be able to impact. Yeah. Yes.
Hi, thank you so much for the presentation.
Of
Building
course.
off that question, can I ask, do you have any other future visions for where your Haptic research will go to further your contributions to the rest of the community outside of education?
And what? Sorry?
You need help with it. So-
Yeah, I would love help. I would love help with everything. Yeah, so there's it's what I find with haptics that's so hard to predict is like, I find that in haptics we're in the same place that the vision community was like in the 1800s. And then it's kind of like when you were first kind of coming up with the very first camera, you know, with the like the little thing that would go poof, and then you would ask a person who's doing that, like, hey, where do you see this going? And like, you know, and then they would be like, oh, we're gonna have like self-driving cars and robots are gonna be able to look at, there's no way, right? And so it's kind of the way I feel we are in haptics, is that I can kind of envision, oh, it would be a much better world, for example, if if you could control robots better, then that would mean, actually imagine you have a robot server, right? And somebody could control that robot server. So then that would mean that people who are paraplegic or not being able to do certain jobs right now because they require some physical interaction that they simply are not able to do, they could do those jobs now. So then that would be really enabling, right? You can also think about all the applications in medicine, where if you now have a virtual environment that you could train in, well, your outcomes might be so much better. You don't need, and for animals too, like you don't need to be opening your pigs up. You can open virtual guy, like it's fine, right? So there's all of that, yeah. But again, it's very hard to predict. Like I'm excited to where it's going, and of course I'm also worried about where it could go. Like I don't want to go into a dystopian future. Like we have so many movies, and then nobody goes out of their house and just their avatar is like running around. Like that's also scary. So I think that's why it's important to do things that are like open source and just put stuff online so that different people can research it. It's not just one company controlling everything, but yeah. Wait, let me, yeah, sure.
Like first, thanks for the presentation, it's really inspiring.
Sure.
My question is like, one day, like people manage to send electronic signals directly to the brain, kind of mimic the sense of touch. Like, how do you like foresee the future of this field? And like, is it fundamentally better to really to touch the object rather than like to just mimic the signal and shoot?
Yeah, that's a really good question. So the question is, what if instead of trying to mimic through a device the sense of touch and like trigger your skin directly, what if you just triggered our brains directly, right? And so I will say that definitely with everything, even say you wanted to taste something like, I don't know, strawberry, like would it be better to eat a strawberry? Would it be better to just like trigger the sense of your brain that like gives you the flavor of a strawberry, and then you would feel it, right? I would say that technology is not nearly there to be able to do that kind of application. Yeah, we don't understand the brains or which areas of the brains are actually doing what. All the time is changing. We're also learning how plastic the brain is also, and how the different areas that do different activities just change around all the time. Like it's not the same area fixed that it's always doing the same thing, right? So I'm sure that at some point you could imagine technology to do that. It's just not, you can't really do that right now. Yeah.
So you could treat that.
Yeah.
You treat this like this field that some kind of transitions towards the ultimate goal. Is it like, is it think this field is like intermediate stage of the optical or?
Yeah, maybe. And I would say, so I'm not sure, like for me personally, as a philosophical question, I'm not sure that for me, the better thing would be to just trigger the part of your brain. Because then, yeah, I would imagine that would get pretty dystopian as well, as in like, oh, I go to the beach, I can just like feel like I'm in the beach. I don't know, like that. It feels pretty, I don't know, like weird, but I don't know. Also, you don't want to stamp technology because there might be good applications with it. I don't know. So I would say for me personally, my goal wouldn't be to get there, but I'm sure that, yeah, some people might want to. Yeah, you had a
We
question.
just take
Yes.
another question, can I ask, Anna
Yeah.
or Melissa, if we could restate the question for those that are joining us on the line?
Yes, absolutely.
I was wondering, did you explore other areas of research before you found this field? Like, or did you just start in this field and like really enjoy it?
Oh, that's very interesting. Yeah, so I would say, yeah, the way I started was I was already, the question was, if I explored other areas of research before I started in this field, or if I just started in this field and really enjoyed it. And so I would say that when I was working at Apple, I was working on haptics. And so I found my advisor who was working on haptics. And so I specifically came to her to work on haptics. And then when I was talking to her, she was asking me why I wanted to do a PhD. So I was telling her, like, eventually what I want to do is go back home and open up schools in Mexico. And so I want more education, right? And so then what she was telling me is like, okay, why don't you then just research how to use haptics for education? So I pretty much just started on this path because I was already very interested in education. Yeah. Yeah, sure. Yeah.
Would you go back to your slide about practice for math? I don't understand that.
Yes, I can. Okay, so the question was to go back to a slide about haptics in math, and then there will be a follow-up question, and this is technologically challenging for me for some reason. And so I will do that, and then probably we should share the screen also. But I think you have to click on. Yeah. Cool. All right. Yes.
So, like, what's the purpose of this?
Yeah, no, absolutely. That's a good question. So the question is, what is the purpose of these in general? Okay. And so the purpose of these is, imagine you don't quite understand trigonometry, right? It's like the first time somebody's introducing the sine function to you. And so usually what happens is you're in class and then somebody draws a triangle, right? And then they're like, obviously, or they'll draw a function, right? and then they're like, of course, you change the frequency and this is what happens, right? And one, it's impossible to draw it very accurately, right? To just be like, oh yeah, changing the frequency by like 0.1 exactly changes the graph by this much, right? And it's so hard to do. And so if you have an interface where you're actually like, and maybe that's not the best interface. Like I say, yeah, maybe my research there is not that good. We could do better. But the idea here is, how do we make something where instead of just looking at a function, we're actually feeling the function and playing with it. And basically the changes that you make on it also elicit changes in what you feel. And so now maybe the concept is not as abstract. Maybe now changes in frequency maybe become gestures that you do, right? If you could like stretch a function. Or maybe you remember the forces that you felt as you were exploring the function, and now the feeling of it, because, and you haven't used a haptic device, which makes it so hard, but basically like if you explore something and the forces go like up and down and up and down and up, and then you go like, ooh, right? But then maybe you go now because the frequency changed. And so the complete feeling of what you felt now exploring it changed. And so now maybe that makes the math be more intuitive, be grounded in something, right? The way we understand any concept is by grounding things. And there's a lot of research that is called embodied cognition, where we are saying like, what would happen if we grounded things in our body, in what we do, in what we experience? And so that's where it comes from.
Isn't it true that you've done some studies to try to determine what the educational impact is, like control studies where?
Yeah, and so, and I would say it's a little hard with educational studies. And like the study that we did this was with 4 students, right? So that's not, and yes, the 4 of them did way better. But it's like, it's only a sample size of 4. The one that we were able to do with a lot of students was the other one, finger perception, where we did use 120 students. But those studies are always very hard. I would say, like, if you want to do research, like in education and technology, it's really a labor of love. Like, I would say you should do it. But you think about, like, if you just do robotics, you just build a robot, you build one, 6 months, publication. you do education, you build a robot, you prove it, then you have to build like 20 of them, and then that's that's like, okay, now it's 2 years. Now you have to go to a classroom, get all the clearances, blah blah blah, stay in the classroom for about a year, and then after all that, so then now after 3 years, you're like, great, publication. And if it didn't work out, no publication, you like start over. so it is hard, but I believe it's rewarding. Yes.
Yeah, so regarding the math thing, do you
Yeah.
think there's a risk of students becoming like over dependent on the technology? Because you mentioned the dystopian future. Like, what if they can't solve the problem unless they are feeling what the function is like? Do you think that's a risk?
Yeah, that's a very good question. So the question was, could there be a drawback of these in that students now are dependent on the technology, right? And they can't actually solve a problem if they're not feeling it or they're using the technology. So that's definitely something to keep in mind, and you always have to do research responsibly. However, there's enough research out there where your brain remembers that, and you are grounding it in your body, in which, like, now for me, because I've played with this so much, when I think of a sine wave, I actually feel the sine wave, and I don't actually need the technology, but I do feel, and it's really weird because I'm not like feeling it with my hands, but I like feel like, so for me, like a very fast sine wave, when I think about like incrementing the frequency, I now feel like, if that makes any sense, and I don't need the technology. So there's a lot of research that it transfers. Yes, sorry about that. I missed you twice.
I was wondering if you could explain the correlation between like musicians and like mathematicians. Like you said, you saw like a correlation between people who are good at music and people who are good at math.
Yes.
Can you explain like how you tested that more and like
Yeah,
what your findings were?
absolutely. So the question is, what if I could explain the correlation between mathematicians and musicians? And the answer is me, no, personally. So I haven't done research in that. It's papers that I have read, but there have been people who have done research in that. And I can't think of the researcher off the top of my head. There has been several, but in which they have shown that people who play the violin or who play the piano at a young age also end up being pretty good at math later on in life. But if you go to Google Scholar, I promise you, like math musician something, you'll see like proficiency. That's the way. you'll find it very quickly. Yeah, I'm sorry about that. Yeah. Yes.
When it comes to like talking about the math education when you're building, so it's like starting with the sine waves. Are you ever going to look into any research like when math becomes more complex, do those like brain waves still fire in that same place, like even when you're then maybe doing discrete math later on?
Yeah, that's a really good question. So the question was if there's I've been thinking, or there's been research being made in which, what if the math now becomes more complex? And so if you start at like sine waves, does that once you're doing something like more like, let's say, topological geometry or something like that, do the brainwaves still work, right? And so again, I'm not a neuroscientist, so I personally haven't done that research, but some of the research that has been done is that in that finger perception study, for example, then they asked, so they, through an MRI scanner, they put people of like a very young age and pretty old people just to solve general math problems. And so they were like calculus and arithmetic and a lot of problems. And they saw that same area, like when people were doing a mental calculation, that same area was lighting up, which basically meant like counting with your fingers, even though they were not using it. So you're right, that's something very interesting to keep exploring and seeing like, oh, how well does this transfer? And do people still need those groundings in your body, even though when you're not talking about very abstract things? Or does it something where it's like a crutch and you eventually just lose it and you're fine, right? But yeah, that's a really good question.
So we're ready to take some more online questions.
The next question is from the webinar, and it goes, what are your thoughts on the adaptive triggers in the PS5 controller? And if you have any immediate thoughts on how that simple trigger might be improved.
Did you get, I did not understand.
Could you repeat the question, please?
On the what trigger?
What are your thoughts on the adaptive triggers in the PS5 controller? And if you have any immediate thoughts on how that simple trigger might be improved.
Oh, the trigger on like PS5 controller, like the
Yeah.
PlayStation 5. Okay. So just, does anybody know it? Because I think it's a voice call actuator, but I'm not entirely sure. Is it the one just goes like pop, pop? I don't know. So I think that it's a voice call actuator. I'm not entirely sure. And so that one is a little bit better than a vibration motor because it's more powerful, and it's basically the way it works is it's a doorbell basically. So you have a coil and you have a metal thing around it. And so when you actuate the coil, it can do many things. So if it has a spring, it can either like bring it back, and then the spring is the one that brings it out, or, you know, it basically moves it back and forth. And so that because it has more mass, so then it's more powerful. It's not just a mass that's vibrates, you can make it vibrate, but you can also make it do lower amplitude, lower frequency signals as well. And so for that, for example, there's another controller out there, which so that again is just something where we're feeling it through the controller. It's not directly doing anything to our skin. There have been other controllers out there. There's a company by Will Provancher. I don't remember the name. It's like Ultra Haptic. No, I can't remember the name, but the man is Will Provancher. He does a lot of skin stretch, for example. So in the controllers, he not only has that voice call actuator, but he also has something where when you're touching it, literally there's like a piece of it that moves back and forth. And so now you're also stretching your skin as you're doing it, which is what happens when we touch real objects. So then that just improves the realism of you're actually touching something out there, for example. So that would be a way to improve it.
Got it. That's it from the online questions.
Okay. Awesome. We have another question in the room.
What was all the question about? What was the statement about? Like, we know how heavy things is, like how far, how much the spin stretches. How does that come into play for like move against objects, or and like continue with that? How do you kind of like replicate that?
Yeah, that's such a good. Okay, so the question was so we know that a lot of the way we perceive the weight of objects comes from the way our skin stretches. So but how does that change with like very dense objects, and how can one replicate that? And so what's really interesting is that our brain is extremely complicated. So yes, some of the way we perceive weight is by how our skin stretches, right? But there's a lot of also that comes into play with like our previous conceptions, our assumptions, what we see, what we've seen in the past, etc., etc. And so, for example, there's a really cool illusion that's called the weight illusion, in which basically you grab a mass and it's the same mass. So let's say I grab 100 grams, and then I put it 100 grams in a very small box and 100 grams in a very large box, right? So then when I pick them up, which one do you all think it's gonna feel heavier? The one in the larger box or the one in the smaller box? Let's see. Okay, let's take a vote. Who votes for smaller? Okay, who votes for larger? Okay, and the answer is smaller. And the reason why is because our brain expects something larger to be heavier, and then something smaller to be lighter. And so I'm already prepared to carry something heavier. So then when I go pick it up, it feels lighter. But then when I have something smaller, I expect it to be lighter, and I go pick it up, and then it feels heavier, right? So that's the reason why. Now that illusion persists also with size, even when I'm not seeing. So if you turn all the lights off and I can somehow sense the size of the objects, that persists. It also persists through textures, through colors. Like my brain, if I have a metal cube, and then I have a wooden cube, and they're all the same weight, I'm gonna expect the wooden cube to be lighter for some reason, and so it persists. It also persists to texture, like I expect something that's more textured to be heavier for some reason, right? Through colors, I don't know why, that's so weird. But yeah, and so all of those things are, I would say, are kind of things, like these illusions are things that we take advantage of more in order to create like haptic environments that like feel more realistic, even though we can't completely replicate the sense of touch. Yeah. Yes.
Earlier you said that you decided to stay in the United States, but you want to get back to Mexico. The access to resources was so profit here.
Yes.
Can I ask what other decisions what other factors affected your decision?
Oh, I got, yeah. No, the question is if there were other things why I stayed. Another thing was I got married. Yes, back there. Yeah.
Okay. You mentioned earlier that you had a startup while you were working at Apple. I was wondering what it was and how you got into it. Was like
Yes. So actually, yeah. So the question was that I mentioned that I had a startup and what it was, etc. And so I wasn't actually, while I was working at Apple, I had it during in my grad school years. There was a summer that I like took off to do a startup with a friend. So basically, yeah, I mean, PhD is really hard. I would say it's really hard. And if you do a PhD, you will go through this. Like there's times where you're like, oh my God, what am I doing here? Like this sucks. Blah, blah. And so I was going through a period where I was like, oh my God, what am I doing here? This sucks. And so I asked my advisor if I could take some time off and do a startup. Also at the same time, like my uncle had just passed away in Mexico, and that was really hard on me. And the fact that you're like here and you can't really see your family that much because you're so busy, like it's pretty hard. And so the idea of the startup was to do kind of like an assistive robot, and it doesn't necessarily move around or anything, but just somebody to encourage you to do your exercises and your physical therapy and to correct you as you're doing it. So basically the way my uncle passed away was he had some heart defect, and then the doctor gave him some exercises to do at home and things that he was supposed to do to take care of himself. We have no idea whether he did it or not, like nobody was checking up him, you know, and then he just passed away. And so I thought, okay, like some people need a robotic assistant, somebody to like keep track of them and monitor it, right? And ended up being that through investors and blah, blah, and probably I can't go into the whole story because still in kind of legal battle. No, that's not true. I'm like, I made peace with it. I made peace with it, but I did get fired, but I made peace with it. I got fired. But yeah, so it didn't end up working out, and they're still out there and they're doing something very different that still has to do with computer vision, very different. But yeah, ended up not working out. Yes.
So I had a question about people with disabilities or visual impairment
Mhm.
regarding haptics. So their brain is wired a little bit differently to pay more attention to other senses. So do you see a difference with those people when they're using your experiment or using your devices, or have you experimented in that?
Yeah, that's a really good question. So the question is the fact that people with visual impairments, their cognition works a little bit different than ours, and whether I have seen any different results with people with visual impairments. And so I will say that in the past, I haven't done experiments with visual impairments. I'm now starting to, because I'm so lucky to have a student that's very interested in working with people with visual impairments. And so we're trying to build now devices for learning for them. And we're still in the process of learning. And so I don't have a good answer for you yet, but hopefully in like a year or two, I will. Yes.
So when we compare like the visual field with haptics, in the visual field, we have a lot of like shortcuts, so to speak. We use videos, which are effectively just pictures that are like sequenced after each other.
Yeah.
And we basically trick the brain in that sense to perceive it as a motion picture. Are there similar shortcuts for haptics, or are we still working on that?
Yeah, it's a really good question. The question was the fact that with video, we use a lot of shortcuts in order to trick people. And so, for example, as you know, movies are just a collection of images that we play at a specific speed to trick the people into believing that it's a video and a movie, right? Instead of just pictures. And so with haptics, actually, what's funny is that we're still learning about how the sense of touch works and what are those pixels and how we could trick people. But there are a lot of tricks that we do actually with our sense of vision, which you would not think. But a lot of the times, because we expect certain things to feel in a certain way. So if, for example, I have one of these kinesthetic robots where I'm just holding onto an end effector and I'm hitting a virtual wall, right? There's only so much stiffness. So this virtual robot is going to be controlled by some motor, right? Like some motor is going to control that joint. There's going to be a limit to how much force that motor is going to be able to do, no matter what I do, right? And so, but when I hit an actual wall, there's almost, of course, every material has a breaking point, etc. But if you think a brick wall or something, there's no amount of force that I can do to just break through that wall. Whereas with most robotic arms that are just reasonably expensive, there is an amount of force that I could potentially do and just go over the maximum force that it could render to me, right? And so what we do in haptics is we actually, if you use vision and you see that like your cursor is like you're moving your cursor around and then your cursor hits the wall and just stays, even though the robot technically is passing the point of the wall, you feel as if it was stiffer because you're expecting it to be stiffer. It looks like it's stiff, so you're like, oh, it's stiff. Same for softness, right? There's only so much softness that we can render because ideally we would be able to render free space. Like if I was holding a haptic device like a robot, this should weigh nothing, right? I'm just moving in free space. But of course, like the robot has a weight associated to it, and like it feels like something. But again, with just graphics and making it like, oh, now you're in free space, or you're moving through a very like airy environment, then your brain feeds into that sense as well. And so those are the kinds of illusions that we do. And of course, there's a lot of others. If you're curious, you just Google haptic illusions. It's super interesting. There's just so many. Yeah.
Okay, so we're about to wrap up. I would just like to wrap up with one last question regarding what has been something that you took from Mexico and that you still keep here, and what would be like your last advice to anyone who wants to go into this field?
Sing like teddy bear? No.
No, like no, like something that you learned living.
Yeah, no. I would say, and that's something that I would love to bring up to you guys. I would say like kindness. I think that because in Mexico, it really is really hard to live there if you're by yourself. Like the services just don't work. It's not like you're gonna walk into a hospital and be like, treat me. No. Like you have to know somebody who knows somebody who knows somebody, And so because of that, I feel like it's a much more collaborative environment where it's like, and it's the same here. It's like, no matter if you're like, oh, I want to be the best at blah, blah. No, I mean, just, help out. Like, like who cares? And you're not going to be able to solve all the problems. It's much better if you just help each other out. And then together you just solve everything, right? Even if sometimes you're like not the first author, oh, who cares? Like you'll be the first author in the next one or the next one, like, just like help out, be kind to each other, find good friends, find your people, the people who are actually gonna bring you up, stick to those people, and you'll see you'll do much better. Yeah.
Thank you very much.
Thank you, Melissa, for your time. Thank you, everyone, for actively participating. We are closing the online session now. Thank you.